Good morning, all. Today we are going to discuss about single phase transformer. So just we have to know that single phase transformer is a static device which convert electrical power from one circuit to another circuit without changing a frequency, because it is a working in the principle of induction. So let's see the elaborated information about a transformer. So that is first we have to recall what is the energy transformation. I just now I mentioned it is one form of electrical energy is that is transferred to the other circuit, and voltage level may be decreased or lowered, that is increased or decreased without moving the parts. So mutual and what is the principle we can using the uh, mutual induction. And these are the topic we are going to discuss: what is transformer, construction working principle, and EMF equation, and efficiency of losses and real world applications. Today's session we are going to discuss. First, we have to see the concept, that is what is the principle. Wherever anyone you have to ask you all, what is the principle the transformer will work. That is without any delay, you have to say that is a mutual induction. And that is the primary the AC flow through the primary coil, and wherein the magnetic flux is produced, which is induced in the EMF in the secondary coil by the principle of mutual induction. And there are a construction of single phase transformer. It consists of main parts, core, windings, and insulation, and tank and oil. So core is provide the magnetic path for the fluxes, and it is made up of laminated steels also. Here there are laminated steels are shown in the figure. And winding, there is a primary winding and then secondary winding. So primary winding is connected to the supply, and the secondary winding is connected to the load. There is a separator is using that called as the insulation, and providing cooling and protection, we are using the tank and the oil. And normally a single phase transformer, just now we are saying that is a single phase transformer is the, there are two winding as there. One is the primary winding, and another one is the secondary winding. And it is laminated for the high graded silicon steel we are using to make a primary, that is core. And based on this, we can avoid the eddy current losses and hysteresis losses. And for the enamel insulation, for the plate, that is thin layers, it is also reduce the losses. And there are two type of transformer is there based on the construction. One is core type, and another one is the shell type. So here I have shown the core type. So core type means there are it consists of two verticals and horizontal section is the dukes. And it may be minimize. What is the purpose we are using the core, that is core type? It minimize the leakage flux, and half of each winding is placed in the each limb, right? And there are two windings are arranged in the concentric coils, are known as the cylindrical winding. That is the two coils are only, it is one low voltage winding is placed in the next to the core, and high voltage winding is over the low voltage winding. And it is reduce the insulation requirements. So this is the core type transformer. And shell type transformer consists of three limbs. So one is the primary, secondary, and the central limb. So each winding is subdivided into two parts. One is the LV section and the HV section, that is the low voltage section and the high voltage section. And sandwich of these devices we can make in a shell type transformer. Normally the transformer is made in the shape of U, T, and E, and I shape is shown in the figure. That is the U shape, I shape, and this I shape, and the orange color shows the E shape, and T is the that is this blue considers the T shape, and this orange is look like a U shape. So based on this, the core we are making. And working principle, we know that it is the Faraday's law, electromagnetic induction. And according to the Lenz law, we are producing N1, D5, and dt. And that is therefore that is EMF induced in the primary, that is E2 E1 which is equal to N2 N1. That is from the primary side we are giving the supply and it is produce the EMF that we called as the E1, and along with this there is a current is flow through the circuit of the primary which called as the N1. There is a flux is produced in this circuit, that is the maximum flux, that is phi m, and here there is a output session in the secondary winding. The secondary winding we are considered as the N2, and EMF is induced through the mutual principle in the N2 that we called as the E2, and the current is I2, and the secondary winding is given to the load. And normally there are two type of transformer is there. One is the step down and the step up. So step down means the N1 winding is more number of winding is available in the primary side, and number of windings minimum number of winding is available in the secondary side. Based on the voltage we are deciding the number of windings in the primary and the secondary. If number of winding is minimum in the secondary, we can say it is a step down transformer. If more number of winding is available at the secondary, then N1 we can say it is the step up transformer. And there are empathy, we are already we know that there is a empathy, define, ideate, and prototype and the testing. So user define the power utilities, industries, and the consumers based on the needs. We are pinpoint the empathize, and we are define the ideate, define and ideate, and then we can make a product type. And these are the applications we are using the real world. Is power supply units, step up, step down in the transformer, charges, adapter, building sets, isolation transformer in labs and hospitals. And we can summarize what is the electrical transformer, what are the core types, and perform the merits and demerits and efficiency losses and applications we have discussed in this session. So let's say this is reference I have made here. That is, if you have any doubt in this session, please ask me. Thank you all. See you in the next session.